This is the question from JEE Advanced 2026. This is a numerical value question from the chapter Gaseous State, and it is a moderate level question. If we solve it properly, it is not very tough to calculate the final answer. So I will read out the question. Two cylinders, both fitted with frictionless pistons, are filled with mixture of helium and argon gases. In the first cylinder, the mass of helium and argon are m1 and m2 respectively. In the second cylinder, the masses of helium and argon are m2 and m1 respectively. The molar mass of argon is 10 times the molar mass of helium. We already know the molar mass of helium is 4 and that of argon is 40. So it is 10 times. The external pressure applied by the piston on the first cylinder needs to be 5 times that on the second cylinder so that the volume of gas mixtures in both cylinders are equal. So we have in both cylinders we have equal volume and at the same temperature. Temperature is also equal. Both have different pressures. Assuming helium and argon behaves like ideal gases, the value of m1 by m2 is, so you have to find the value of m1 divided by m2. So we have two cylinders, cylinder 1 and cylinder 2, both have pistons which are frictionless pistons, and in first cylinder we have masses of helium and argon. Here we have helium and argon. Mass of helium is m1 and that of argon is m2. In second cylinder we have helium and argon, but their masses are m2 and m1. Both have same volumes, both have same temperature. Temperature and volume is same, but pressure on, this line is very important, the external pressure applied by piston on first cylinder needs to be 5 times than that on the second cylinder. If we have pressure P here in second cylinder, if we have value of pressure is P, then on this first cylinder we have pressure is 5 times the pressure on second cylinder. So if pressure is P here, then pressure will be 5 P here. So you have to just use the ideal gas equation and calculate the ratio of m1 and m2. So applying ideal gas equation to the first cylinder, we have P, which is 5P, into V is equal to number of moles, given mass, m1 by 4 number of moles of each gas, and here we have m2 by 40, and here we have number of moles m2 by 4 and m1 by 40. You can take these values as x and 10x as well, but it will not change the answer. It is given the molecular mass of argon is 40 times, so just you have to take the 10 time value. Answer will not change if we change these values as well. So we have P for first cylinder. First cylinder we have P V is equal to number of moles m1 by 4 plus m2 by 40 into RT. For second cylinder we have pressure P, volume V is equal to number of moles m2 by 4 plus m1 by 40 into RT. So simply I will put this PV, if you take the ratio RT and RT will cancel out, and we have 5 PV here and PV here. So P and V also cancel out. So we have 5 is equal to M1 by 4 plus M2 by 4T divided by M2 by 4 plus M1 by 4T. So you can cancel out the factor of 4 as well. I will multiply it here and cancel out the factor of 4 as well. So we have 5 times M2 by 4. Okay, I will cancel out later. So we have M1 by 4T is equal to M1 by 4 plus M2 by 4. So 4 cancel out the 4. We have 5 times M2 plus M1 by 8 . So I will cancel out the factor of 4 as well. So this 4 will cancel out. Here we have 10. This 4 will cancel out. Here we have 10. So 5M2 plus 5M1 by 10, that is M1 by 2 is equal to M1 plus M2 by 10. So I will subtract M1 minus M1 by 2. We have M1 by 2 on the right side, and 5M2 minus M2 by 10. 5 minus 1 by 10. 5 minus 1 by 10 times M2 is equal to M1 by 2. This is 49 by 10. So we have 49 by 10 is equal to M1 by, we have M2 here, is equal to M1 by 2. So we have M1 by M2 is equal to, I will multiply 2 here, it is 98 by 10. So what we have to find in this question is the value of M1 by M2 is, 9.8. So simply the answer will be 9.8. So you have to just use the ideal gas equation 2 times and take the ratio and solve little bit. You will get the answer 9.8. That's it. Thank you.